Okay, students, so we are going to continue with our exploratory data analysis. So what we did earlier is we actually read, of course, we have done some basic plottings, right? We did on the bar plot and also line plot, and also have we done the scatter plot? No, we have not done the scatter plot. We only did the line plot, right? And we have also have learned how did we actually combine two graphs on the same plot. And we were actually exploring on the housing data set. So whenever we load, this is a CSV file, so we are using the CSV. Okay, this is big enough. So use a CSV and make sure that whenever you're reading from the same directory, so you don't have to put the directory path. But if you're reading from other directories, you have to put the directory path. And do you remember what is the function head for? What does this function head does? Yeah, it'll show the first 5 entries. And how about tail? The last one. So this is good for us to actually have a visualization of the data frames. You can see we can actually visualize how the data looks like. And furthermore, what we did, we actually can use the function shape. This one comes without the bracket. So it will show the row, number of rows, 5,000 rows, and also number of columns. We have 7 columns, right? This we have done before. And there is also this function info. So make sure you know all these functions, because these are the functions that you will be using for your project 1. So when you use the info, what does it actually show? It shows the range of index that you have, how many entries. Then it shows how many entries in total, and it also gives you the index from 0 to 4,999. And also it gives you on the columns, total number of columns, and it gives all the names of columns, and it gives the index of the columns. And also it gives you the non-null count. So this is quite important also for us to see whether we have missing data or not, one way. So when we see 5,000 non-null means, okay, there are no missing data, and you can see the type, data type. So this is float, means is all numeric value, right? Except for object is, except for address, which is object, which means it's a string, address, right? So does it make sense? Are you able to decipher something about the nature of this data set? Any question up to this point? Then we also going to use something that we have used before, which is what is the function that we use to know the distribution of data? Do anyone remember? Anyone remember? What's the distribution of the data? 25%, 50%, 75%. What is the function? You all remember? We did it a few times, right? Just did it in our previous class also. What is that? That shows you the standard, min, max. Describe. Yes, very good. It's describe. Oh, sorry. Have to redo back, have to run back on the data frame. I have to define also on the. So let me see. Do I have that before? Okay, I'll just run this back again. Okay, so now I can run back that one. Okay, I'm just reloading this back. Which one on it? Shape on it. For done and describe. Oh, sorry, spelling mistake. So what does describe do? It only takes the column which has numeric attributes, right? And it shows. So you'll see that earlier when we looked at the info, all the columns except for address, which is actually the data types object string. See, all are listed here, right? 1, 2, 3, 4, 5, 6. 6 of it. It actually shows the number of count, and also what is the mean, what is the standard deviation, what is the minimum, and what is the max, and what are their distribution. Right? This is how I actually can use the describe function for us to see the data distribution is like. Now there is another function also. Earlier we have actually seen here. Actually, by right here, the non-null count, it shows the value. You can actually, but here what it shows is, it shows the non-null. So if you want to know the null values, what you have to do? You have to take the non-null, you have to take the total entries, you have to minus with the non-null, then only you will know the null, how much is null value, right? Are you following what I'm saying? This actually shows the non-null count. So let's say if there's 4999, in order for you to know the null number, you actually have to minus with the total number, which is 1. But there's another easier way for us to actually find out to get the null number is by using the housing underscore price. You all have this data set, right? I've given you this notebook, so type along. This one is the function is null. This is the function is null, and this will identify all the nulls within each rows, and you want to use sum it all up. So it shows the sum of all the null values in every attribute, in every column. So of course you'll get the sum is 0, right? So the house pricing is null, it will find each null values, and we want to sum it all up, so it shows the sum. So here's another way to find out is there any null values or not. And previously we have done, right, when you identify null value, what you can actually do with a null value, whether you want to substitute it with median value, average value, minimum or maximum, all those things that you can actually do. We have done it before. So see, let me something here. Okay, so now let us try to earlier what are the things that we plotted? Oh, we didn't plot anything yet, right? We haven't plotted anything, right? So now let us actually try to have our first line plot. So we are going to try to plot the average area income versus the price. So what is the function? The function that we're going to use, you're going to use plot PLT, because this is what we have defined the matplot library as PLT, right? We have imported that as a PLT, and we're going to use the function plot. And what is the argument that you need to provide? You need to give your, of course, your data frame. This is housing price, and you actually need to provide the x-axis value and also the y-axis value. So the x-axis is going to be the average area income. So take note that the names must be same. Okay, in order for you to find out the name of the column, so maybe what you can actually do is housing price is the columns. Sorry, not this. We have to call the object. Sorry, column. Yeah, columns. So housing price dot columns will list out all the columns the name of all the columns. So we are interested in plotting average area income, this one, versus the house price. So of course, there are various reasons why we want to make certain plot. So in this idea, why we are looking at average area income and also the price of the houses, can you make some relationship with that? Can you make some relationship? What do you think? If you find out that particular area's house pricing and also that particular area's people's income, how would it help? Yeah, maybe the developers can actually do such, calculation to find and see that the people earning of that area is so and so much, and the prices of a house is so much. Could they actually afford to buy? That's one thing you actually can see. Or another thing, you can see the house prices that's much. You can see the people's income that much. Or they are very well-to-do people. So maybe you can label that as a, like a high posh area. So a lot of insights that you can actually derive from this analysis. A lot of analysis that can do. So here, of course, for the sake of practice, we are just plotting the average area income and the price. But what I'm trying to instigate is that, what is the story behind it that you can actually tell? What is the insight that you can actually find out from this graph? Okay, so the reason why we actually find out from the column is that we have to make sure that we specify the names of the columns exactly. So we're just going to copy from here. So we are going to plot this one. This will be our x-axis. X-axis comes first with versus the y-axis, which is the housing, price, and this is price. Is it capital P or small p? Capital P. So to make sure that you follow the attributes correctly. Right, these are the arguments that you actually have given. Now we also have the option of selecting the color. So let's say if you want to use color red, so you'll get red in color. And you can also use marker. Marker is every data point, how you want to set the marker. So either could be X or 0. So let us try to set as O, using O. That means round point. Later we'll try using X also. So let's give a name, and also these are the things. This is how you use the function plot. So remember that whenever you just mention plot, by default it is a line plot. Right? Later we'll see some other plots as well. So these are the things you can actually provide the x-axis value and the y-axis value. You can also set the color. You can also set the marker. Then let's try to give the title and label names. Do you remember how do we actually give title? Plot, and of course title. This one we're going to name it as average area income versus price. And you can also have the option of setting the font size for the title. So let's say 14. So later on, when we actually explore, when you visualize, you can see if it's big or small. You can play around with the font size. Then what we want to do, we also want to give the x-axis label and also y-axis label, right? So we use x label. So what is x label? Basically, x label is the average area income. So we just can copy paste this. You can also set the font size. Let's say you want to set font size to 14. So these are the options. Then we can use the plot y label. This is large enough. If you can't see, just let me know. So y-axis, y is going to be price, right? Now there's another option that we didn't actually set earlier. Plotting also enables us to set the grid. So grid, when it comes useful, whenever you have the grid, sometimes it's easier for you to draw for you to visualize and see which data point is it closer to. Earlier we didn't use grid, right, in the point. So we also have that option. We can actually turn on the grid by providing true. So if you don't provide grid, then it won't be there. And with all these settings, finally, we can use plot show. So let's see. So you're able to see the font size, you can see the price, you can see the average area income. So one question, this type of plotting that we are doing now, is it univariate, bivariate or multivariate? What is it? Bivariate, that's one answer. Any other answer? Bivariate. I did mention it's important, right? Yes, it's bivariate because you're trying to find the relationship between these two variables, right? It's bivariate. So what can you decipher from here? You have a lot of lines. Does the line make any, does it convey anything? When you use line chart, does it help? In this case, when you use the area, average area income and so price, does it help compared to the previous one when we're using a line chart? Because this line chart is a simple one that we have actually done. The simple line chart. Is the line chart useful in this? I mean, in terms of showing a relationship between the average area income and also the price? No, because there are too many points. There are too many points that, the lines are just interconnecting here and there. It doesn't give any insight. Are you all following? The way how the lines are moving, it's not showing anything. So that means for this kind of plots, line plot is not suitable. So we actually have to use what we call as a scatter plot. Actually, you can already see the scatter, right? When you use the marker point, you can already see the scatter. But here the line is just too many lines are there. Then the line doesn't make any meaningful contribution. So for this case, this is also important for you to understand when you have certain data, what type of plots or charts that we should use. So there are too many observations. Line plot doesn't actually give you a clear idea what's happening. And doesn't show the relationship between these two variables, right? Sometimes earlier when we have the line plot, that we actually use this one. Of course, this is actually a very simple one that we actually did, right? The line chart. It actually clearly shows the relationship between x and y. It's a coordinate point, right? X is this, y is this, x is this, y is this. But here there are too many lines, and it doesn't give any. It doesn't give the clear relationship between these two variables. So therefore, we can actually use the scatter plot. So this is actually quite useful to visualize any two variables in two dimensions. So we actually use dots, right? Earlier we used the O marker. So we can actually also use marks, X. So scatter plot is a much more better way of how you can actually observe the relationship between the variables. So if you can see the increase in one variable causes an increase in another variable and vice versa, then what we can infer that there is a positive linear relationship between those two variables. However, if you see the other way around, which means if the first variable reveals a decrease in second variable, that means it's a negative linear relationship. Later we will see again when we draw, do we have a positive linear relationship, or do we have a linear relationship So let us actually try to generate a scatter plot now between those two things, average income and also the price. So there's one thing that you can actually use to adjust the figure size. That is by using this function which is known as RC parameters. So this is also false, sorry, not plot, parameter. So this is also falls under the plot matplotlib function. So this is RC params. So using this, earlier we didn't decide the figure size, right? Using this you can actually determine the figure size. So this is one thing additional that you can actually do. So the figure and the fig size. So this is sorry, you have to use a single quote. Okay, thank you. It's better. Thank you for the feedback. So under the RC params, you have to define the figure size, fig size, right? So you can determine this as 6 by 4. So later we can actually change the 6 by 4 and see how it actually affects the dimension. So 6 usually refers to the Y dimension. The 4 refers on the Y dimension. Okay, so later if you want to make it big, we can actually try to change. You can see the effect. So now let us use the scatter plot. Now the scatter plot is the same thing as how we used before. So I'm just going to copy paste only. Let me copy. We can just copy this whole thing. Excuse me. So this one, instead of plot is by default is using line. So here we're just going to change to scatter. So this is same, x-axis, y-axis. So same. Let's keep it same. The color red and marker also keep it same. And then the title also same, X label, Y label same, grid is same. Then you can actually show the true plot show. So the only thing that you actually change here is what you added one, which is to show the figure size, and also you change this one, the scatter. Others are the same thing, right? So let's see when it shows. There you can see the plot. So let's see what happens if you don't put this one. Or let's see also. It's giving the default thing. So let's see if we change this to 12 and 8. Now it becomes bigger, right? Can make it much more bigger. So when it just change the figure dimension size. Now, a quick question. Just now we just saw on. Okay, remind. I'll just make this a bit smaller. And put 8 and 6 perhaps. Okay, lah. Something you can view, right? Now, based on this scatter plot, what is the relationship between the average area income and also the price? Does it have a linear relationship? Are you able to see? Does it have a linear relationship or no? Why do you say yes? Yes, you can see that. Excuse me. Yes, you can see that Even though it's not a line graph, right? Linear relationship must be easier to see line graph, but do you see that the whole distribution is actually going up? As the price is increasing, the average income also is increasing. Do you see that? So that shows, and also it's going up, right? So this is the positive linear relationship between the average area income and also the price. What does this actually show you? This is actually, okay, this data is actually what is the housing prices, right? Which means people have already bought the house. People already bought the house and they are actually staying in that particular house. What does this tell you? The price of the house and also the income of the person who's actually living in that house. What does this tell you? I'll pause the recording for a while for discussion. So this is basically showing you people with a lower income, they tend to buy a house with less, of course, a cheaper. Those who are earning more, they tend to buy. There's some category who actually able to buy a very costly house. Why? Because they're earning that much. Makes sense, right? So this kind of relationship, you can see that it's positive linear relationship. Negative means you'll see the other way around. It will be decreasing. Right? These are the things that we were actually trying to see. Any question up to this point? All okay? This is what we have actually discussed just now, and also the RC param option to set the figure size, so it's not a problem. So you see, if the let me just make it big. So if the points or the dots are color coded in a scatter plot, additional variable can actually be shown in the same 2 dimension. So let's say if you want to plot the average area income against price and also average area population by color coding plots on the same figure. But wait, I think before that we got exercise, right? Yeah. So this is exercise for you. Before we actually do that, I think that one is the next space. Yeah. So before we do that, this is exercise for you. Do this plot now, but plot area population versus price. Use scatter plot, but make it blue and use the X marker. Can you do that now? Use the RC params function also. You can set whatever size that you want. So I just pause the recording for a while. This is for your class exercise. So this one, what are the things that you change? This will be area population, right? Area population, this is price, this will be blue, this will be X. You just change the O to X. So you want to change the area population, the title. This one will be area population and the price. So you'll be able to get the plot right. And what is the relationship? Again, also has more or less a linear kind of relationship, like positive linear relationship. You can see it from the visualization. Okay, now what we actually described earlier is what if we try to plot 2? So if you can actually do the points or dots in color coded, then we can actually show more than one variable. So what we're going to do is, let's show the average area income against price and also average population against price by using the color coding. So we can give some color code, right? So let's try to do that. Let me enlarge this. So let us actually do the scatter plot. What is the function for scatter plot? Plot, you're going to use scatter, and then we need to provide the x-axis value, which is the housing underscore price. This one is, we are giving the average area income is the first one. This will be versus with housing price. This is price, right? And this one, let's say this one we can actually give the color red. Color, we give it a red color, and we can also use a different marker for this, right? Let's say we use the round marker, comma marker. We'll use it as O, right? So this is what we're done for this. So you can actually copy this whole thing also, the whole line, plot scatter. And the only thing is you're going to change the color, the next one, to blue, and you can use X, the marker. And this one we are doing against what? This is area population. Area population. Okay. Then we give the title, plot title. This is what? Average area income versus price. This one because we have two, right? So we can actually put average area slash population versus price. We can also set the font size. So maybe we can put 14 for now. Then the X label. What's the X label? The X label is definitely average area income. Average area income is what? Red, right? So we can actually put red. Then comma area population. This is blue. And we can set the font size to be the same as well. Again, do for the Y label. So Y label is nothing but the price. So we can change this to price. Then we can actually use the plot grid. We can actually turn it on, true. Okay. In this case, we also must use plot legends, because we have two, right? So we want the legends to be displayed for this two. Great, true, done. X, Y label, title, scatter, done. So now we can actually use plot show. Okay, some error. What's error? Let me try to see. Average area income, X label. X label is not found. Oh, my mistake. I didn't use the plot. Yeah. All right. So now we managed to get a graph. Everyone got it? So you can see that both average area income and also the area population seems to have a linear positive relationship with price, right? So you can see some relationship with this. And where is the legend? The legend is supposed to appear. Is the legend there? Let me try to put the legend, plot legend, showing. It's not. Is it not showing the label? Oh, okay. No artist with labels found to be put in legend. So one thing that we added is we added the label for each line, and automatically when we actually plot the legend, it takes the label and put it both together. All right. Thank you. So any question up to this point? So basically we have been using the same kind of approach for the line plot and also for the scatter plot. And also the same approach that for us to set the title, the label, the legend, and the grid, and also the plot show. The only thing that we did for the legend was we added the label, and automatically it actually appears here. Any question up to this point? So let's try now another exercise. So this one, try to plot the average area or number of bedrooms versus the price. So here you can actually see that you may find some certain patterns here. So this is the power of visualization. So the thing is, use scatter plot, use blue, and also use the X marker. You'll be able to see some distinct kind of relationship between the number of rooms, average area number of rooms, and also versus the price. Managed to get? Do you see some distinct pattern? So what is it that you can see? What is a story that you can tell behind it? It's a simple story that you can tell, right? But what is it? Guys? Sorry? The variable doesn't depend on each other. Okay, that's one. What else that you can actually tell? This one is the average area number of rooms. So if we look at the data set, this is actually what is this? Come. This one, average area number of rooms. It's not just number of rooms, huh? It's average area number of rooms. What is the story, you can tell? So why you can actually see this distinct kind of pattern is, there are certain area number of rooms. So you see, this is not number of bedrooms. If number of bedrooms, you can actually see 2, 3, 4, 5, like that, right? But area number of bedrooms. So they take the area of all the number of bedrooms. So if that's why you can actually see a distinct pattern. The houses that has 2 bedrooms may have a certain number of areas, right? With this 2 bedrooms. So that's why you can see from area 2 until a certain range. This is the number of area. Then there's a number of area for 3, number of 4, 5, 6. So that's why you can actually see some sort of range between the average area number of bedrooms. So even though if you have 2 bedrooms, the number of 2 bedrooms can vary, right? Number of 3 bedrooms you can actually vary. 4 bedrooms and 5 and 6 bedrooms. So you can see it varies in terms of the average area number of bedrooms. So that's why you can see a much more clearer, distinct categorization. In other words, this clear kind of distinction means 2 bedrooms, 3 bedrooms, 4 bedrooms, 5 bedrooms, 6 bedrooms. So which number of bedrooms are, do you think, the most available? 3 most. You can see this one also is quite packed. 4 also. So you can see 5 bedrooms and 6 bedrooms are a bit lesser, right? From the density of the scatter. 2 is also okay, but more on the 3 and 4 bedrooms. So in that particular area, the number of bedrooms are around like 3 to 4. There are 5 and 6 also, but not that many houses out of the 5,000 houses. Then there are 2 bedrooms also. But you can see the most are 3 and 4. So this is how you're trying to look for some story behind. What can you actually see? What can you deduce from here? And later on, maybe you can actually see the price also, the average number of bedroom, and for the, of course, this is with respect to price. In terms of price, you can see that the 3 average bedrooms are also can be on same par as the 6 bedrooms, right? Some of it are having almost the same price. So these are some of the things that how you want to try to look the background story of what the data has. Okay, we'll take a 5 minutes break. Okay, we are continuing with the plotting. So what we have done is we have done with the line chart, we have done with the scatter, multiple scatter, with color code and also different markers, and also with the legend. Now we're going to move with the box plots. So for this box plot, make sure that you've also uploaded the, not for box plot, for the upcoming exercises, you need to use the new data set which I actually uploaded. So make sure you use that. That's the iris data set. So now we're going to look at a box plot. So we have actually done this box plot before, And it's also known as the box and whisker plots. It has the whisker, it has the box, and also has the whiskers, right? Which actually displays a summary of the function that we used before, which is known as describe. So the describe is in numerical format and it shows you the distribution, but box plot gives you the visualization of that describe. So what is the minimum value? Of course, this is not including of the outlier. What is the first quartile? What's the second quartile or median? What's the third quartile? And what is the maximum value excluding any outliers? So very quickly, just a quick revision. So you can see how a box plot is being determined. So we have the minimum, we have the Q1, the lower quartile, we have the median, upper quartile, and also the maximum. So this is known as the whiskers. So any data that falls out of this whiskers are known as outliers. And remember last week we actually saw how do we actually try to deal with outliers. And this range from Q1 to Q3 is known as interquartile range, IQR, and we did the calculation before, right? So we can actually use the box plot using any one of these three libraries. So let's try to do one. We enlarge this. So we can straight away use the plot matplotlib function library that we have created, object plot plt. So we can straight away just use the box plot, and in the box plot we can actually pass the range of the values. So just can hantam any value lah, 0, 1, say 10, 15, 4. You can also put negative values also, no problem. Let's put some few negative values, whatever. Can be from positive to negative value, so not a problem. Put extreme the one also. Just can put whatever value that you want. Not an issue. Whatever range of value that you put, it will plot. So that you use the plot show. This is same lah. Oh, sorry, because this is a new notebook, right? So we can actually copy and paste everything from the earlier one. I forgot about that. Let me just close this. Put here. Sorry, this is actually not marked down. This is cool. So we run the code. So now we can do the box plot. So immediately it shows you the box plot. So based on the range of values that we have actually entered in, it will actually show what is the minimum value. And it will show what is the maximum value. But you see that this 40, it actually identifies as outlier. So remember how we actually found the outlier? We actually find the interquartile range, then you actually minus with the maximum value, you got what is the range, then you plus it. So anything that's more than the maximum considered value is known as outlier. So what we can actually decipher from here is we can actually see that most of the data are concentrated around this range. And the maximum can consider based on the interquartile step is up to 30 and is on 20. So anything that's more, this is considered outlier. So box plot gives us that visualization. So now, of course, this value we actually gave on our own. We can also use the random generator. So now let us actually use the random generator, the numpy random, and we are going to use the random and function. Excuse me. So now we are using the random n function. Now is different from earlier. We actually use the random integer function. So this one uses the random n function, which means it allows us to, it actually takes two input arguments. The first one is the number of arrays that to be created, how many arrays that you want, and also the number of values within each array. So you're creating some sort of like a data frame, right? Columns and also rows. So let's see how we can actually do that. So let's create a data frame which is known as my frame, and we are going to use the panda data. We're going to create the data frame. So we need to use that data frame constructor, right? This is data frame. And now we are going to use inside the data frame. We're going to use this random plot function. Are you able to follow? We're creating a data frame. Usually, how do we create a data frame? The first way is we pass a dictionary object. We create a dictionary and we pass the dictionary object. The second is by creating a matrix, right? So here, how we want to create the matrix, we use the random operating function. Random function. Now this one requires two inputs. Which one comes first? Number of rows and also column. And we can actually have the option to give the columns the names. We have done this before. So let's say we give them as column 1, column 2, and column 3. Okay, this is much more easier for you all to see, right? Then now we can actually the box plot using the my frame data, and you generate box plot with the name the columns as right now. Before this, let's try to view the my frame first. Okay, so we have created this my frame value. So 3 columns and also 10 rows. So you call the box plot is actually equals to my frame, so the box plot, and with plot. So once you have the my frame, you can straight away use that my frame dot box plot to have the plot. So somehow or other it actually works a few options also you can actually do, still plot the box plot. So this still does the job. So each time when I generate, it actually generates a different plot because of this random value. So you can see the distribution, that you can see some of it you don't have the outliers. So some of it now you can see some outliers that are there. This is randomly generated numbers. So you can see the various generation numbers there. So in the first column you can see the median or the most or the center point of the data distribution is somewhere around here. And this is the maximum, this is the minimum. Likewise you can see for the column 2 and also column 3. But sometimes you can see some outliers that are there. So from this visualization, it is important for you to take note of, oh, there are outliers, and what do you want to do with the outliers. Again, we actually made the discussion right last week. If the data set is B, what do you want to do with the outliers? If we just want to remove them. Remember that why we are doing all this visualization is because the next step is we're going to do the modeling. If you don't handle all these outliers and things like that, that will be taken into consideration into your model generation, and your model won't be accurate. So you need to handle all these outliers. Excuse me. Histogram. So far we have seen the line plot, we have seen the scatter plot. So each one of this type of charts can be used to describe certain type of data types. So not, you have to try to look at the data type that you have. If line is not appropriate, you use a scatter plot. And now, of course, we also use the box plot. So that's a very useful visualization. So all these things that you learn later on, you'll be using it as part of your EDA, Exploratory Data Analysis. When we next week, Monday, when we will look at all these various things. Maybe next week when you're doing your exercises, each and every one of you need to choose a different data set. Of course, we'll give the link. I'll give the link of where you can actually download your data sets. And you choose a data set, and maybe you need to use scatter. Maybe this person have used histogram. Maybe that person has used a different way. Different styles of visualizing your data. So not all the same. So here histogram is, of course, this actually gives you the frequency distribution. So this is the highlight. So this allows us to discover the underlying distribution of the data by visual inspection. Of course, to pass the histogram, we actually pass the numeric values of the method histogram. So let's try to plot the distribution of values of the price columns of the USA housing data set. So this histogram, we are actually going to use the same thing, also plot, but we are going to use his. So let me make this big. Histogram function, and we need to provide the attributes inside. So what we want to do now, we want to actually look at the price, right? So this is Alama. Okay, you'll have an issue here. I just realized this because we never created this data frame in this notebook. Okay, so we have to do something back here. So before this, we just put here. Is it the same directory? Yes. And now we can plot show. Okay, some error. Let me check. This now I was typing halfway. I didn't put which column. I just put housing price. You notice that? So this one's supposed to be price. Yeah. So what does this actually, now can we actually make this graph much more readable? Y-axis and x-axis, can we actually do something about it? What is actually the x label? Sorry. Is actually the price, right? And what is actually the y label? Number of houses, right? Remember, histogram is actually showing you the frequency. So if you look at this, which one is the highest price? Which price distribution? This is 1 by the power of 6. So this is what? 1 million, right? This is half million, 1 million, 1.5 million, 2 million. This is 2.5 million. So which one has the highest range? This one, 1 million bar. This has the most number of houses. Do you see that? This means out of the 5,000 houses that we have actually plotted, approximately, I do not know what's the exact number here, around 1,200 houses are within that 1 million range category. So there are some so this is the 1 million range category. So what does it actually tell you? What does this graph show you? This graph has what we call as the bell curve, right? The Gaussian distribution. That means the most number of houses that area out of the 5,000 is around 1 million, the price. Then you can see that the curve drops down, right? The number of houses that are lesser than 1 million is lesser. Less than that is lesser, less. More than 1 million, of course, little bit around less than 1.5 million. Still there, but it's the second highest. Then you can see when it goes more than 1 million, the number of houses are reducing. Going closer to 2 million, also reducing, and come closer to 2.5 is very, very less. So what does this tell you? That most of the people there are millionaires. I see most of them have 1 million dollar house. Not bad. Right. Second one is more than 1 million, right? So these two bars in the center, most of them are. So it's quite a well-to-do area. All are millionaires. They have $1 million houses, and this is how the distribution is. So the range is their houses value is not so less, only few people, and more than that, maybe they cannot afford anymore. So we have that kind of bell curve. So these kind of things that we want to do under the exploratory data analysis to try to find out this kind of reasoning behind it. So this is what we have actually discussed. So by default, the method histogram uses 10 bins or groups to plot the distribution of the data. Currently, does the price have groups? The price doesn't have groups, right? It's actually a continuous, it's a value range of number. It doesn't have groups. So what it does, by default, it actually separates into bins by itself. So you can see by default, it actually breaks it down in 10 bins. Like the graph before. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. By default, it breaks it down into 10 bins. Or groups, but currently because the price is not based on groups. If you have a like categorical thing, then of course you can break it down to groups, right? Which category repeats comes the most. We can also change the number of bins by using the options bins. So let's say we take the same one, copy this, go back here, paste it here. We don't have to read this one back. This is on it. We're using the histogram. We can add the option bins. So let's say if you want to break it down to smaller portions so that you can really see the actual number of prices that are there. So let's say instead of 10, you go to 100. Now you can see the distribution much more clearly. Like, but that means what you're doing for, you're breaking down the range much more smaller. So when you break down the even more smaller, you can see that around 140 houses around here. For each of this bar, it has a particular number, right? So still you can actually see the distribution is the bell curve, and the highest is somewhere around here. So when you add all this point, like for example 100, 140, 120, like that, you can keep on adding, then the middle range from 1 million to 1.5 will come up to 1002. Now you just broke it down to smaller chunks. Is this okay? So it's quite interesting to see that, of course, in this case, the house price follows a normal or a Gaussian distribution, which is known as the bell curve. So many machine learning algorithms assume the Gaussian distribution features. So why is it important for us to look at this distribution is to see whether whenever you see this Gaussian distribution, it means that your distribution is well distributed. Whenever you see it is skewed towards the left or right, that means there's a tendency of biasness in your data. So we will discuss further when we actually do machine learning on the effects of why you actually need the Gaussian distribution, and what happens if you get a data that is skewed to the left or right. How does it, when you have a data that is skewed to the left or right, your model also tend to be biased. So you don't want your model to have a certain sort of biasness, right? So later we'll have more discussion on that. Now it's a bar chart. So earlier histogram is, when you have a categorical or discrete data, earlier when you want to see the frequency, you can actually use the histogram. Even though the number of prices are not in groups, you can group them by using bins. By seeing, okay, 1 million houses, how many houses are within that range. So you can see the numbers for each category of price. Let's say if you have the categorical or discrete data that actually uses a small set of values, then we can actually use the bar charts. Just give me a moment here. Like for example, here is given, like the USA data set has a continuous range for prices for houses. So the continuous range, definitely what we have actually used before. We can actually use, if you draw just the house price, you can actually use line chart you can use. Can you use the scatter for the price? Guys? You can still use the scatter, right? Earlier we actually did for the price, right? It scatters all the price. And then what we did, box plot, definitely you can use. You can find a description for the price. Then what we did, histogram. Yes, histogram actually shows the frequency, but because now this we're talking about the prices of the houses, right? The houses are discrete in number, so we can actually group them between the range, right, by using the bins. So you can find the houses ranges from 500 to 1 million. How many houses? So histogram shows you the frequency of the number of houses within that range of price. So, but now if you want to use bar chart for house pricing, it's definitely not suitable, right? How you want to actually show a continuous value by using because bar chart is a discrete value, right? You need to show a discrete bar. It's a bar chart. But because the price has a continuous range, so you can't, if you want to do bar chart, you will be doing bar chart for 5,000 bars every, right? So it's not really suitable to draw the bar charts for this data set. So therefore we're going to use the other data set for exploration, which is the iris data set. This is also a very famous data set is being used. So this iris is not your eye iris. This is actually an iris plant, and it has 3 species: Setosa, Virginica, and also Ivesicolor. So there are 3 species of this plant. So make sure you have loaded that in your same folder. So let's try to read that data now. Have you all uploaded into the same directory? So let's call this as our iris dataset. So we are going to use the Panda library to read from the CSV and make sure you know the name of the file. I asked everyone to actually upload, but I forgot to upload. So just hold on. So yeah, I also just only uploaded the file. So make sure you get the right name, iris dataset, and don't forget extension CSV. So let's try to get some info on this data. So what are the info that you can derive from here? How many rows, how many columns do we have? 6 columns. What else? How many rows? Guys, is there only right? How many rows? 150 there? 150. 150 entries, right? And of course, total 6 columns. Do you have any missing values? We don't have any missing values, right? So it says that there's ID. So let's later after this see what is the ID. It's all about. You can see that the sepal length in centimeter. Sepal means it's like the flowers, the side there, you have the bud, so it's known as a sepal. Petal is, of course, the petal, right? This is talking about the iris flower. There is the sepal and also the petal width. So the sepal is like the flowers, one part that's coming out. What is the sepal length, and also what is the width, and also you have the petal. So if you search for sepal and petal, so yeah, this is a good image for you to explain. Sepal is when it's a bud time, it closes, right? When it comes up, the green part is a sepal, and petal is of course the leaf petal. The flower petal. Okay, can understand? This is the sepal and this is the petal. Go back here. So each species will have a certain type of sepal length and also the width, petal length and also the width, and also what their species are. And we also have this ID. So later we can actually see what are the so let's try to see iris data. Let's use the head. So we can try to view how it looks like. So you can see how this is how your data set looks like. You have the ID. ID may not, maybe it's a unique ID for each one, the sepal length, sepal width, in centimeter petal, and also the species. What is it? Is it Iris centosa or whatnot? So since we are actually interested in identifying the species, let's see what are the range of species that we have. So wait, let me just enlarge this. Okay, look at iris. Oh, it's 150 already. Iris data. Let's look at the species column. Because just now the head we couldn't see much, right? It only shows the first one only. So you can see the whole range of it. Iris centosa, Iris virginica. So again, when you type species, it also shows the head and also the tail of the boat. Okay, we will actually just pause here. We'll continue. I'll do the recording and I'll just send because I still owe you all another 2 hours of lecture. So I'll try to make it in a small chunk so you can watch it and we can continue from whatever we stopped in Friday. Is that okay?